Okay, so we are working right now on problem number 8 from 13.3a. But in order to visualize this problem, I want you to be looking at the picture on 2b because it has a picture of what we need to see. All right, so let me read number 8. It says, what is the longest line segment that can be drawn in the interior of a right rectangular prism that is 12 centimeters wide, 15 centimeters long, and 9 centimeters high? So if you look at 2b, it has a segment labeled X. That is what we're trying to find right now. But the length and width and height of the rectangular prism that we are using is 12, 15, and 9. So first of all, let's just consider the base of that rectangular prism. And that's what I have drawn right here. The base of that, we're going to call it 15 by 12. And if you use the Pythagorean theorem, 15 squared plus 12 squared equals x squared, or equals hypotenuse squared. And then take the square root of both sides, you get root 369 is the hypotenuse of that base. And then you have to draw another right triangle with that hypotenuse is the bottom of your new triangle. The height of the rectangular prism, which is 9, they told us, we can put there. And then we use the Pythagorean theorem again, 19.2 squared, which is root 369, plus 9 squared equals x squared. And when we do that, we get root 450 equals x. And so our longest line segment that can be drawn in the interior of the right triangular prism is the square root of 450. Now, if we had started differently, instead of choosing 15 and 12 for our length and width, let's say we had done 9 and 12 instead and worked out the problem, then we would have gotten a lower x. But I was just smart about how I chose my my initial length and width because I was going after the longest possible length x there. Okay, what questions do you have about that?